Due to cumulative errors and the lack of loop closure, there may be misalignment or non-parallelism between floors. When this data is opened in the 2D window with X-ray display, it is evident that there is a significant misalignment between these two layers of data. Then switch to the 3D window, and use the profile to check the data. For data that is misaligned or non-parallel, GCP transformation can be used to improve it. This involves manually selecting ground control points between different layers and using these points for correction. An easier method for selecting control points is to choose points in places where the structure is consistent between the upper and lower layers, such as columns and corners where the planar coordinates and elevation difference are identical. The elevation difference can be obtained through measurement. First, through the profile. Find a location where the elevation difference is relatively easy to measure. The point cloud at this location is relatively good. Measurement can be performed. The measured elevation difference is approximately 3.488 meters. Then find another place to measure and confirm. The measurement at this place is 3.492 meters. Then select another place to measure. The point cloud at this place is not very good, so choose another place. The measurement at this place is 3.49 meters. The elevation difference is basically determined to be around 3.49 meters. Then exit the profile. Use the cross-section function to remove the upper point cloud, making it easier to select the ground control points of the first layer. Turn off X-ray, turn on EDL enhancement. Display the point cloud by intensity to distinguish between walls and the ground. Then click on the Pick Multipoint. Sequentially find suitable locations on the first layer to select control points. After selection is complete, you can perform a check. If a point's elevation is significantly different from others, you can reselect the point. Then click Save to save to the 3D point. When saving, only the point's index and XYZ coordinates need to be saved. Then right-click to solve the task. Open the file path. Open the control point file with Notepad. Copy and paste all the control points. Then modify the index. Then, for the copied points, adjust the z-value. Add the pre-measured elevation difference, approximately 3.49 meters. After editing, delete the file header and then save. Return to the MLS interface and open GCP Optimize under the SLAM process page. Then import the points we just edited. Note that XY should correspond. Double-click the first point to jump to the location of the first point. We can then select the points to be registered. Select each point to be registered in sequence. After selecting each point, you can rotate to different angles to check. Then click Accept GCP to start processing. After processing is complete, close the GCP function. You can open the X-ray display in the 2D window, setting the point cloud to display by time. You can check the GCP registration effect. At the places where we set the point pairs, the point cloud has basically matched together. But there are still some deviations in places where point pairs were not set. You can place more ground control points at key locations to achieve better optimization results.